In this video, we're going to cover LangChain vector stores, and also we're going to have a look at LangChain's indexing API and what this means about when you're doing data ingestion into your vector databases. Firstly, you're going to have to run a couple of Python imports for this, and I'd recommend running this specific notebook on a local computer rather than inside Google Colab, because we're going to also run a Docker command as well. So you'll need to install LangChain, LangChain OpenAI, and LangChain Elasticsearch and Face CPU. Once you've installed those, we're going to import a couple of different things. So a text loader, OpenAI embeddings, a character text splitter, and Face, which is another vector database. Now, if you haven't already, you'll need to set up your specific OpenAI API key. And we've just got some raw text here that we're just going to write to a file. And then once we have that file saved locally, we're then going to load that in with the text loader. And we're then going to split that into chunks of 1000 at a time with no overlap. And then we're going to split those into LangChain documents. So you can see here, you get a list of LangChain documents. And then we're going to load our vector database from this. And this is just giving you another taste of the fact that there's lots of different methods on side of the vector database that you can use. So if you do db. You'll see you can add lots of documents, add embeddings, you can add text. And the interesting things that are quite important are, for example, you've got the ability to look at the index. You can also save this, but I specifically recommend having a look at the similarity search. So you'll see when we do a similarity search for digital marketing, at the moment we only got one document. And you can also see the actual, this gives you a tuple object, and each of these has both the document and the relevance of that document. Now you can also change the K as well, so that's quite nice. Now if we have some more documents, you can also load documents specifically from LangChain documents. And you can see here we've got two documents here. We've got the page content of James Phoenix, and we've also got the page content digital marketing is a growing industry. Now, the important thing when you're doing LangChain indexing is to remember to add specific bits of metadata, because it's going to use both the page content, so what's inside the page, as well as also hashing your metadata dictionary, as well as hashing the page content together to create a unique ID that's kept inside of a record manager. So that's really important that you add specific metadata to tell the LangChain indexing exactly where these documents came from, so that when you do then start using an indexer on those, you can effectively deduplicate the documents. So you can see now if we look at the different LangChain documents, we've also got that metadata associated with both our documents, and we can add these documents, and Face will give us back a unique index ID for these documents. And we can do a similarity search, and if I do for James, you can see I can lock in the K at 1, and we can see that the document that you get returned is this James Phoenix worked in digital marketing for 3 years. And also we've got that metadata as well. Now, the problem is if we don't use indexing or a record manager, there's no way to know necessarily when you need to re-ingest your documents whether anything's changed. Without knowing how those documents have been indexed, it's very difficult to keep track of specifically what documents need to be re-ingested, what vector database bits of the vector database need to be pruned and deleted or updated. And this means that you want to solve this problem. And so LangChain have come up with a really nice way of solving this called the indexing API, and I've linked to that inside of here. And basically how it works is you've got a couple of different components. So one of the components is a record manager, and the record manager basically says we'll take the document, which is a hash of both the page content and the metadata, and then what you can do is you can then deduplicate based on that document hash. And so when new documents are ingested, if the page content's changed or the metadata has changed for a specific document, then you need to do some different types of operations to clean the vector database. There's different types of deletion modes, and we'll cover that towards the end of the video. For now, what I'd like you to do is just have an example of this. Now, you will need to have Docker installed on your local machine to run this. And what I recommend doing is copying this Docker run command, loading up a terminal window, and then running that Docker run command. And that will ask you if you want to install a load of packages. And you'll see here for my example, we're loading Elasticsearch. And basically this is a vector database that we can use locally. Now, what's interesting about having an Elasticsearch installed from a Docker container is then we can load that up on this port. So it's localhost 9200. We've got an index name, and we've got the embeddings coming from OpenAI embeddings. Okay. Now, you also are going to create something called the SQL Record Manager. And remember, the SQL Record Manager really does a couple of different things. What it's mainly doing is it's mainly storing what documents have been indexed, what is the document hash, and then it allows you to keep track of specific records. So I can run this record manager.create schema, and that creates the database schema. And then what's interesting about this is we're just using SQLite at the moment, but you could use any SQL database you want for storing the specific types of records. Now, let's see what happens when we pass in a document that's got exactly the same kind of metadata, but it has different page content. So you can see if we scroll up, the page content was James Phoenix worked in digital marketing for 3 years. But now we're saying that James Phoenix worked in digital marketing for 7 years. So we've updated one document. Also, you'll see here we've got this little helper function which allows us to clear content. So we're going to go and clear the index to start with. Then we're going to go and with the documents we've already created, which are just above here, you've got these documents here. And what we're going to do is we're going to add those specifically to the index. And what you'll see here is because our record manager was cleared, basically we've got 2 documents. And so for the first time, we're saying use the source ID key. So this is the key that we're dedupling against, which is the original source. And we're basically saying with my record manager, is now going to say for this vector store, insert these documents. Now what's interesting about this is if we have these documents here, and you can see I've got these 2 documents, if we then were to rerun this exact same command, and because we're using this cleanup incremental, so because these documents haven't inherently changed, there's nothing that's going to happen here. So when you see when I rerun this, it skips adding any documents because the document hash hasn't changed. Now, if I was to then update one of these documents, so if you see here, we've got these updated docs where we've said James Phoenix has worked in digital marketing for 7 years. When we try and update a single document, we actually end up deleting one of those documents based on the source and then adding a new one based on the fact that document has changed and we've re-ingested it into the vector database. You can also see what it would be like to add a new document. So if we just had a new document with a new different types of metadata, you'll see that we've got a num added, but we haven't necessarily got any that have been updated, skipped, or deleted. And also, if we already have something that's the same, then essentially what's going to end up happening is you can see we're skipping the document. So from the document that we just tried to insert, because nothing has changed, we're getting a skip document. Now there's 3 modes that you can operate the index API in. We've been primarily using the one that I recommend, which is incremental. And so what happens with incremental is it deduplicates content for each individual document as you re-ingest it. Now, if you do full, it will do that at the end of the indexing. And if you do a cleanup mode of none, then basically it's up to you to clean your specific vector database. So again, the key points of this video and for you to take away is always make sure that you add on metadata to your LangChain documents. You can have a record manager, and that will be a database. So you can see here, I've got this record manager, cache.sql, but you could have this specifically in any kind of SQL database that you want, whether you're using Postgres or whether you're using MySQL. Essentially, all you need to do is change this DB URL and add on the various connection strings with the namespace. And then that's an important point. The other important point is remember to pick the mode that you're most interested in. So I would recommend using incremental. And the reason why all of this is important is because this means that you can have a re-ingestion pipeline that's powered by a record manager and a vector store, and then it's being deduped by this source ID key plus a document hash, which means that when you rerun your ingestion, it doesn't have to always re-ingest every single document, and you can have smarter ingestion pipelines inside of your vector database. Cool. I'll see you in the next one.